How can the essential question today is how can you use addition or subtraction to solve an equation? The objective is to use addition and subtraction to solve equations. Now guys, listen, I know we've worked throughout the year solving equations, different situations, whether it's our warm-up problems or so forth. I mean, we've talked a lot about solving equations. Quite honestly, a lot of this you already know how to do based on what we've done with our warm-ups. But I will present the lesson. I will go slowly, and this way, hopefully, anyone that has still had any questions about anything, those questions will be answered. All right. So let's start with some of the basics, and one of the basics here is the idea of first of all, what is an equation? And an equation is simply a mathematical sentence that says one thing is equal to another. Okay? If I take a look at this example here, we're saying some number plus 3 is the same as 7. Now I know most of you guys can do this in your head, right? Probably, I'm sure all of you can do it in your head. What number plus 3 is the same as 7, right? We all know that the answer is going to be 4. Okay? The solution of an equation is the value that makes the equation true. So 4 is the only value for x that would make this equation true. It is 4 plus 3 that is the same as 7. But it's the bigger picture that's more important here, guys. Understanding what we mean by an equation. All right, and I can't stress that enough. What an equation is. It's a mathematical sentence that says one thing is the same as another. Okay, and that overarching idea is going to guide everything that we do. All right, so let's take a look at some examples. If we're checking solutions, we want to be able to tell whether the given value is a solution of the equation. If you look back at the previous page, the word solution means it is a value that makes the equation true. We want to know, is P the same as 18 in the following equation? The equation reads a number plus 10 is the same as 38. Well, I think all of us know what number plus 10 is going to be 38. All right, but the question is that number 18? Well, what I'd like for you guys to do is to show your answers mathematically. So your first step is to replace the variable with the number. So I'm going to replace P with 18. All right, and I do that using parentheses. And then I'm going to recopy the plus 10, recopy my equal sign, and recopy the 38. If I add 18 and 10, it's going to give me 28. Is 28 the same as 38? And the answer to that is no, right? 28 does not equal 38. So 18 is not a solution, right? That would be a no. If I take a look at the second example here, 4 times a number, that's the way I would read that. I don't read that as 4y. I don't want my students reading that as 4y. I want to read that as 4 times a number is equal to 56. 4 times a number is equal to 56. And I want to know, if I replace y with 14, will that equation be true? Right? If it is true, it means that 14 is a solution of that equation. Okay? So I write 4, I replace y with 14, and I show that using parentheses. Is that equal to 56? That's our question. I replace the variable with the number. I perform the operation. 4 times 14 is going to be 56. Is 56 the same as 56? And the answer to that would be a yes. All right? So if I'm checking solutions, my first step is to replace the variable with the number. I perform the operation, and I want to see if I get a sentence that's true. If it is true, it is a solution. If I get a sentence that is not true, then it's not a solution. All right? So let's go ahead and take a look at, these examples here. All right, on your own. Tell whether each is a solution or not. All right, now I'm going to show the work, but I know you guys can do these mentally, but you guys also know I don't accept that, right? I want you guys to show your work. All right, you're going to write these out. So if you're doing problem number 1, a number plus 6 is equal to 17. And I want to know, is 9 a solution of that equation? So I'm going to replace 9 for A. So this becomes 9 plus 6 is equal to 17. Well, 9 plus 6, that's going to be 15. Is 15 the same as 17? The answer to that is no. All right, so 9 is not a solution of that equation. All right, let's try problem number 2. We have 9 minus g, and I want to replace g with 3. So I'm going to replace g with 3. And is that equal to 5? I want to know if g makes this if 3 makes that equation true. 9 minus 3 is equal to 6. Is 6 the same as 5? Right? The answer to that is no. Right? So that means that g is not a solution. 3 is not a solution of that equation. All right? Let's try example 3. All right? 35 is equal to 7 times some number. And I want to see if that number is equal to 5. So I recopy. 35 is equal to 7 times, and I'm going to replace n with 5. Well, what is 7 times 5? Well, 7 times 5 is 35. Is 35 the same as 35? Right? The answer to that is yes. Right? So we write our equation. We replace the variable with the number. All right? I see if the equation is true, or I see if it's not true. Problem number 4. How would I read this equation? I would read this equation as a number divided by 2 is equal to 28. And I want to know, will 14 make that equation true? So I'm going to replace q with 14. I'm going to divide it by 2. And will I get 28? Well, what is 14 divided by 2? Well, 14 divided by 2 is 7. Is 7 the same as 28? And the answer to that is no. All right, so the first part of the lesson, where we're identifying if a value is a solution of the equation, we write the equation by replacing the variable with the number. Right? I do the mathematics, and I evaluate. Is the equation true? If the equation is true, then it's a yes. If the equation is not true, then the answer is a no. We had 3 no's with these examples. All right. Now, we want to be able to solve equations, and this is something that you guys have already done, and we've talked about this all year long. You can use inverse operations to solve equations. Inverse operations undo each other. Addition and subtraction are inverse operations. So when we look at the key idea, if I have the equation 8 is equal to 8, right? That is true. 8 is the same as 8. If I add 5 to both sides of the equation, I'm using my mathematics property, my addition property of equality. By adding both sides the same amount to both sides of the equation, I get an equation that is also true. 13 is the same as 13. That's an example of the addition property of equality, which says you can add the same number to each side of an equation and the two sides remain equal. Okay, so we're going to be using that addition property of equality to solve equations. Right? What does that look like? It would look like this first example here, right, where we are adding 4 to both sides of this equation. The equation reads a number minus 4 is equal to 5. If I use my addition property of equality here, I add 4 to both sides of the equation. Positive 4 and negative 4, they cancel each other out. That's going to be 0. I'm left with x is equal to 5 plus 4 is 9. We always want to check our solutions. Is 9 minus 4 equal to 5? And the answer to that is yes. All right, we're going to be doing the problems a little bit differently, right? But I'm just going through what this slide says here. We're also going to be able to use what's called the subtraction property of equality, which says when you subtract the same number from each side of an equation, the two sides remain equal. If I take that same equation we started with up here, it says 8 is equal to 8. If I take away 5 from both sides of the equation, I get 3 is equal to 3. All right, still an equation that remains equal. 3 is the same as 3. If I'm solving the equation, I see an addition in that equation, and I use the inverse operation of addition, which is subtraction. I use that subtraction property of equality. We take away 4 from both sides of the equation. We get x is equal to 1. I check my answer. Is 1 plus 4 equal to 5? And the answer to that is yes. All right. So let's start solving some equations. And I know most of you guys are really good at this already, but we'll go step by step. The equation reads a number minus 2 is equal to 6. And we're looking for the solution of that equation, the value for x that's going to make that equation true. What number, when you take away 2, is equal to 6? Now, I know all of you guys can do that in your head, but that's not the point. The point here is to learn the skill, to learn the process, and execute that process correctly to solve equations. Okay? How does that process work? Well, first, I want you to recognize the operation in the equation. I see subtraction. Well, if I see subtraction in my equation and I'm looking for the solution, I have to use the inverse operation of subtraction. And if you go back to that earlier slide, it says that addition and subtraction are inverse operations. So if I see subtraction, I want to use addition. How do I show that? Well, I want to show that I'm adding 2 to both sides of my equation. What do I mean both sides of my equation? Here's my equal sign. And my equal sign splits that equation into two sides. I have the left side of that equal sign, or the left side of the equation. I have the right side of that equal sign, or the right side of the equation. So the equal sign is that separation point that says one thing is the same as the other. In order to solve equations, I use the inverse operation. Well, what happens on the left side of the equation? Well, negative 2 and positive 2. They cancel each other out. That's 0. And I always want my students to write that 0. I don't want you to think that numbers just disappear. Okay? When I use an inverse operation, that's always going to give you 0 as a result. So what's left on the left side of this equal sign? All that's left is x. On the right side of the equal sign, I perform the mathematics. 6 plus 2 is 8. Right? So I get a solution of 8. But I check my answer using some mental math. How do I check my answer? I replace x with the value that we just found for x. So I'm going to replace x with 8. And I'm going to see if I get an answer that's true. Now, you don't always have to write this out, but I'm going to write this out initially. So if I replace x with 8, I get 8 minus 2 is equal to 6. Is 6 equal to 6? Right? The answer to that is yes. So I know that that solution is correct. And one of the things we talk about all year is that when we're solving equations, there is no reason to have mistakes or incorrect answers because you have the opportunity to check your answers. I expect you guys to check your answers. All right? Our second example, I want to know. I want to find x. I'm looking for the solution. What is the value for x that makes this equation true? 18 is equal to some number, take away 7. When we solve equations, I first identify the operation. Well, I see subtraction. The opposite of subtraction is addition. So I'm going to add 7 to both sides of this equation. All right? I do the opposite of whatever operations I see on the same side of the equation as x. So when I'm trying to get x by itself, I'm trying to isolate that variable. That's the term some teachers are going to use. So in order to get x by itself, I have to remove this negative 7 using the inverse operation. When I add 7, that's going to be 0. 18 plus 7 is 25. And on the right side of the equation, all that's left is my x. I check my answer. Is 18 equal to 25 minus 7? And the answer to that is yes. All right, so I know that my answer is correct. All right, let's move on to the on your own problems. Now, I'd like for you guys at this point to stop the video, write these 3 examples in your notebook, do the problems using the last 2 problems as your example, show your work, and then restart the video to check your answers. Right? I'll go through these problems in a minute, but right now stop the video, do the problems on your own. All right? Okay. Now, I'm going to pick up and we're going to solve these. What's your thought process? Well, I'm looking for the solution of the equation. I'm looking for the value for k that's going to make this equation true. How do I find that solution? I identify the operation and I see subtraction, right? And because I only see one operation in this equation, it's called a one-step equation because there's really only one step that we're going to use to get to the solution. I use the inverse operation. The inverse of subtraction is addition. So we're going to add 3 to both sides of this equation. That's going to give you 0. I'm left with k is equal to 1 plus 3 is 4. Going to check it using a little mental math. Is 4 minus 3 equal to 1? The answer to that is yes. If I look at my second example, I see subtraction. The inverse operation is addition. So I want to add 10 to both sides of this equation. Negative 10 and positive 10, right? They're inverse operations. That's going to be 0. So I'm left with n is equal to 4 plus 10 is 14. I circle or box my answers. I check it using mental math. Is 14 minus 10 equal to 4? And the answer to that is yes. Remember, when we check our solution, I replace the variable with the number that we just found for that variable. I see if I get something that's true. Okay, this last example, I see subtraction. The inverse operation is addition. So I'd want to add 6 to both sides of this equation. Okay, the opposite, I'm using the inverse operation here. The inverse of subtraction is addition. We know that when I add opposites, they're 0. 15 plus 6 is 21. I get 21 is equal to r. Circle or box my answers, and I check my answer. Is 15 equal to 21 minus 6? And the answer to that is yes. All right, so we continue with this lesson. We want to solve equations using subtraction. Okay, and I look at this example here. I see addition in the problem. Some number plus 2 is equal to 9. When we solve equations, I use the inverse operation. So the inverse operation of addition is subtraction. Well, what do I subtract from both sides of the equation? I subtract whatever is being added here, right? So if I see plus 2, the inverse would be to subtract 2. That's going to give me 0. I'm left with x is going to be equal to 9 minus 2, which is 7. I check my answer, make sure it's true. Is by replacing x with 7. Is 7 plus 2 equal to 9? The answer to that is yes. Okay? If I look at example B, 26 is equal to 11 plus a number. What operation do I see? I see addition. The opposite of addition is subtraction. We're going to subtract 11 from both sides of that equation. That's going to give me 0. 26 minus 11 is what? 15. I get 15 is equal to x. I circle or box my answer. I check it. Is 26 equal to 11 plus 15? And the answer to that is yes. Guys, notice with every single problem, I can see what we're doing on both sides of the equation. If I subtract 11 from one side of the equation, I have to subtract 11 from the other side of the equation. I'm using the subtraction property of equality. And I should have said that earlier. Here, when I subtract 2 from both sides of the equation, I'm using the subtraction property of equality, right? Which says that if I take away 2 from one side of the equation and I take away 2 from the other side of the equation, my equation remains true. If I go back and look at these other examples here, right, was I using this subtraction property of equality here? The answer to that is no, right? I was using the addition property of equality because with these examples, we're adding something to both sides of the equation, right? So I'm adding 3 to both sides of the equation. Whatever you do to one side of the equation, you have to do to the other, right? And once again, each one of these examples, I'm using my addition property of equality because I can see that I'm adding the same amount to both sides of the equation. Okay, so let's continue. Right, example 4, we have a real life application. So I want to write an equation and then solve an equation, right? Write. My laptop is so sensitive here. I want to write and solve an equation to find how much money you had before your parents gave you $20. Your parents give you $20 to help you buy a new pair of shoes. The new pair of shoes are $59, it looks like $95. After you buy the shoes, you have $5.50 left. Write and solve an equation, right, to show how much money you had before your parents gave you $20, right? So what is that going to look like? Well, you had some amount of money. Let's call it S. But then your parents gave you $20. So some amount of money plus $20. Okay? But then, let's see, you have to buy shoes that are $59.95. So you had some amount of money, you paid $20, but then you take away 59, what's that? 95, and then you have $5.50 left. So there's your equation. Okay? Now, if I'm using my properties of equality and I want to get the variable by itself, my first step here, let's add 59.95 to both sides of that equation. That's going to be 0. So now I'm left with S plus 20 is going to be equal to what? That's 5. 5 and 9 is 14, carry the 1. 1 and 5 is 6. 6 and 9 is 15. 5 carry the 1. 1 and 5 is 6. So we have 65.45. But I'm still not done. I'm still looking for S, right? How much money we had before my parents gave me $20. I use the inverse operation here, the opposite of addition and subtraction. So we'd subtract 20 from both sides of that equation. That's going to be 0. So S is going to be equal to, right, if I'm subtracting 20 here, that's 5, that's 4, that's 5, and that's 4. So I had $45.45 left. All right, we write the equation. I use my addition property of equality with my first step by adding 59.95 to both sides of the equation. How do I know that I'm using addition? Because the inverse of subtraction is addition. My next step, I see addition. So I'm going to use my subtraction property of equality to get my solution. Okay. Now you guys have these problems here that you're going to do on your own. You're going to check them. Once again, I'd probably say stop the video. Okay, try them on your own and then restart the video to check to see how you did. All right, I'm going to pick up with problem 8 right here. I'm going to recopy problem 8. I thought I did that though already, no? Okay, so if I recopy problem 8, right, that's going to look like this. So we have s plus 8 is equal to 17. I'm looking for the value for s that makes that equation true. The opposite of addition is subtraction. So I'd want to subtract 8 from both sides of the equation. I'm using my subtraction property of equality. That's going to be 0. So I'm left with s is going to be equal to 17 minus 8. That should be 9. I check my answer. Is 9 plus 8 equal to 17? Answer to that is yes. Problem number 9. Copy my equation. 9 is equal to a number plus 6. I'm going to use my inverse operation here. The opposite of addition is subtraction. So I'd want to subtract 6 from both sides of the equation. On the left side of the equation, that's going to be 3. The inverse operations cancel, and I'm going to be left with y. I check my answer. Is 9 equal to 3 plus 6? The answer to that is yes. Problem 10. 13 plus a number is equal to 20. I use the inverse operation here. The opposite of addition is subtraction. So I'm going to subtract 13 from both sides of the equation. That's going to be 0. I'm left with m is equal to 7. I check my answer. Is 13 plus 7 equal to 20? Answer to that is yes. All right, and let's try problem 11. You eat 8 blueberries, and your friend eats 11 blueberries from a package. There are 20 blueberries left. Write and solve an equation to find the number of blueberries in a full package. Okay, so if I'm doing problem 11, I use a variable to represent what I don't know. So I'm going to start with my variable n. Right? But n represents the number of blueberries in a full package. But then I eat 8. That means I'm going to take away 8. And then my friend eats 11. So I'm going to take away 11 more. There are 23 left after that happens. Right? And we're looking for n. I simply want to use the inverse operations here. The inverse of minus 8 or subtracting 8. Going to add 8 to both sides of this equation. That cancels. That's 0. Left with a number. Minus 11 is going to be equal to 31. My next step, the inverse operation of subtraction is addition. So I'd be adding 11 to both sides of that equation. That's going to be 0. And I'm left with n is going to be equal to 31 plus 11 should be 42. So there are 42 blueberries that we started with in the full package. All right, I'm going to stop there. All right, you guys can play around with the practice page. I'll attach that. All right, you guys can practice that. Should be pretty simple though. You're just checking to see if they are solutions. And then here you're using the inverse operations, right, to solve the equations. I don't know, 8 looks kind of weird, so let's do 8 together. All right, I don't want anyone to freak out with that. It says 2/5 plus some number is equal to 5/6. Okay, I want to get m by itself, so I'm going to use the inverse operation. The inverse of addition is subtraction, so I'm going to subtract 2/5 from both sides of that equation. That's going to give me 0. So I'm left with m is equal to whatever 5/6 minus 2/5 is. So I'm going to have to go over to the side of my paper. 5/6 minus 2/5. I'm going to have to make equivalent fractions. New denominator is going to be 30. That's times 5. This is times 6, so that's times 6. 25/30 minus 12/30. Looks like that's going to be what? 13/30. 13/30 for m. Right, so don't let a problem like that bother you. It's still going to be done the same way. We identify the operation in the equation. I use the inverse of that operation. The inverse of addition is subtraction. I'm using my subtraction property of equality. Whatever we do on one side of the equation, we have to do on the other. Right here we have to make equivalent fractions, and we subtract. All right, you guys are going to work on the exercises for 7.2, and I hope that's been helpful. All right, hope to see you guys soon.